When dealing with electrical panel modifications, specifically the relocation of neutral bars and alterations to wire termination practices, it's crucial to adhere to manufacturer specifications and industry standards to ensure safety and proper functionality. In this case, the relocation of neutral bars in 83G OEM 120/208V 400 amp panel boards with Type EG interiors raises several concerns. One significant issue is the maintenance of adequate wire termination space. The original design of the panel board likely accounted for a specific amount of space, typically between 11 and 15 inches, to facilitate proper wire bending and termination. Altering the location of the neutral bars without considering this requirement can lead to overcrowding, difficulty in making secure connections, and potential strain on conductors. The stacking of compression lugs on the studs provided on both the phase bars and neutral bar presents another area of concern. While it might seem like a space-saving solution, stacking lugs can compromise the integrity of the connection. Firstly, it's essential to verify that the studs and the panel board itself are designed and rated to accommodate multiple lugs. The added thickness of stacked lugs can reduce the effective thread engagement of the securing hardware, leading to a weaker connection. Secondly, achieving proper torque on stacked lugs can be challenging. The lower lug might not receive the necessary pressure to create a secure connection, increasing the risk of loosening over time. This can result in increased resistance, heat generation, and potentially a fire hazard. The use of a 200% neutral bar, which accommodates 4/4/0 wires with 2 on each stud, further emphasizes the importance of proper termination practices. While a 200% neutral bar is designed to handle a higher neutral current, it also requires careful attention to ensure each connection is secure and capable of carrying its share of the load. The difference in compression lugs used on the parallel feeders, with some having long barrels and 2 crimps versus others with short barrels and 4 crimps, is another critical issue. Parallel feeders are intended to share the load equally, and using mismatched lugs can disrupt this balance. Lugs with different barrel lengths and crimp configurations may have varying resistance, causing one conductor to carry a disproportionate share of the current. This can lead to overheating, premature failure of the conductor or termination, and potential damage to the equipment being fed. To address these concerns effectively, it's recommended to contact GE Technical Support directly. Their phone number is 1-866-997-8089, and their email addresses. You can also reach out to specific technical engineers, such as the electrical product manager or the electrical engineer. When contacting GE Technical Support, provide them with the specific model and series of the panel boards involved. This information will help them provide accurate and relevant guidance. Additionally, refer to the following resources for detailed information on GE panel board wiring instructions, neutral bar location, and compression log requirements. Firstly, the GE panel board wiring instructions document, available at the provided link, offers comprehensive guidance on proper wiring techniques and termination practices for GE panel boards. Secondly, the GE panel board neutral bar location document, also accessible via the provided link, provides information on the correct placement and configuration of neutral bars in GE panel boards. Thirdly, the GE panel board compression log requirements document, available at the provided link, outlines the specific requirements for compression lugs used in GE panel boards, including information on proper crimping techniques and lug selection for parallel feeder applications. When evaluating the existing installation, consider the following points. Firstly, verify that the relocated neutral bars are properly supported and secured within the panel board. They should be mounted in a way that prevents movement or vibration, which could loosen connections over time. Secondly, inspect the wire termination space to ensure it meets the minimum requirements specified by GE. If the relocated neutral bars have reduced the available space, consider alternative solutions, such as using offset lugs or reconfiguring the wiring layout to improve accessibility. Thirdly, assess the torque on each compression lug to ensure it meets the manufacturer's specifications. Use a calibrated torque wrench to verify the torque and retorque any connections that are found to be loose. Fourthly, replace any mismatched compression lugs in the parallel feeders with identical lugs that meet GE requirements. Ensure that all lugs are properly crimped using the correct tool and die, and that the crimps are inspected for completeness and proper alignment. Fifthly, consider conducting a thermal scan of the panel board using a thermal imaging camera. This can help identify any hotspots or areas of elevated temperature which could indicate loose connections or overloaded conductors. Sixthly, if necessary, consult with a qualified electrical engineer to develop a corrective action plan that addresses all identified issues. The engineer can provide guidance on proper wiring techniques, lug selection, and other aspects of the installation to ensure it meets all applicable codes and standards. When dealing with electrical systems, it's always best to err on the side of caution. If you have any doubts about the safety or integrity of the installation, seek professional assistance. Modifying electrical panel boards requires a thorough understanding of electrical principles, codes, and standards. Improper modifications can create safety hazards and potentially damage equipment. Proper wire termination is a critical aspect of electrical safety and system reliability. When terminating wires in electrical panels, it's essential to follow industry best practices and manufacturer recommendations to ensure a secure and long-lasting connection. Firstly, always use the correct size and type of wire for the application. Refer to the National Electrical Code, or NEC, and local electrical codes to determine the appropriate wire size based on the ampacity requirements of the circuit. Secondly, strip the insulation from the wire carefully, avoiding any nicks or damage to the conductor. Use a wire stripper tool to ensure a clean and consistent strip. Thirdly, when using compression lugs, select the correct lug size for the wire gauge. The lug should fit snugly over the conductor without being too tight or too loose. Fourthly, crimp the lug onto the wire using the appropriate crimping tool and die. Follow the manufacturer's instructions for the crimping process to ensure a proper and secure connection. Fifthly, after crimping, inspect the connection to ensure it is free of any defects or damage. The lug should be securely attached to the wire and the crimp should be uniform and complete. Sixthly, when terminating wires on terminal blocks or busbars, ensure that the screws or bolts are tightened to the correct torque specification. Use a calibrated torque wrench to verify the torque and prevent over-tightening or under-tightening the connections. Seventhly, label all wires and terminations clearly to identify the circuits and equipment they serve. This will make it easier to troubleshoot and maintain the system in the future. Eighthly, when working with aluminum conductors, use an antioxidant compound to prevent corrosion at the termination point. Apply the compound to the conductor before inserting it into the lug or terminal block. Ninthly, avoid overbending or stressing wires when making terminations. Wires should be routed smoothly and neatly without any sharp bends or kinks. Tenthly, when terminating multiple wires on a single terminal, ensure that the terminal is rated for the number of conductors being terminated. Do not overload terminals or exceed their capacity. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. Firstly, ensure that the electrical panel is properly grounded to the building's grounding system. The grounding conductor should be sized according to the NEC and local electrical codes. Secondly, bond all metallic enclosures and equipment to the grounding system. This includes metal conduit, junction boxes, and equipment chassis. Thirdly, use grounding bushings or bonding jumpers to ensure a continuous ground path between metal enclosures and conduit. Fourthly, inspect grounding connections regularly to ensure they are tight and free of corrosion. Fifthly, when working with sensitive electronic equipment, consider using a dedicated equipment grounding conductor to provide a low impedance ground path. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Firstly, always consult the latest edition of the NEC when designing or installing electrical systems. Secondly, familiarize yourself with the specific requirements of the NEC that apply to your project. Thirdly, follow the NEC guidelines for wire sizing, overcurrent protection, and grounding. Fourthly, ensure that all electrical equipment is listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. Fifthly, obtain all necessary permits and inspections before starting any electrical work. Electrical safety is paramount when working with electrical systems. Always follow safe work practices to prevent electrical shock, burns, and other hazards. Firstly, to energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Thirdly, never work on live electrical equipment unless it is absolutely necessary. If you must work on a live circuit, use extreme caution and follow all applicable safety procedures. Fourthly, maintain a safe working distance from energized parts. Fifthly, use lockout/tag-up procedures to prevent accidental re-energization of the circuit. Sixthly, be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Seventhly, never work alone on electrical equipment. Always have a qualified helper present to assist you in case of an emergency. Eighthly, if you are not qualified to work on electrical equipment, hire a licensed electrician. Electrical work should only be performed by qualified professionals. Overcurrent protection is a critical safety feature that protects electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds the rated capacity of the circuit. Firstly, select the correct size overcurrent protection device for the circuit. The size of the overcurrent protection device should be based on the ampacity of the conductors and the load being served. Secondly, install overcurrent protection devices in readily accessible locations. This will make it easier to reset breakers or replace fuses when necessary. Thirdly, label all overcurrent protection devices clearly to identify the circuits they protect. Fourthly, inspect overcurrent protection devices regularly to ensure they are in good working condition. Replace any breakers or fuses that are damaged or defective. Fifthly, never bypass or tamper with overcurrent protection devices. Doing so can create a serious fire hazard. When working with electrical panels, it's essential to maintain a clean and organized environment. A cluttered panel can make it difficult to troubleshoot problems and increase the risk of accidental contact with energized parts. Firstly, keep the panel free of dust, debris, and other contaminants. Use a vacuum cleaner or brush to clean the panel regularly. Secondly, organize the wiring neatly and securely. Use wire ties or cable clamps to bundle wires together and prevent them from hanging loose. Thirdly, label all wires and components clearly. This will make it easier to identify circuits and troubleshoot problems. Fourthly, avoid overcrowding the panel. If the panel is too small for the number of circuits being served, consider upgrading to a larger panel. Fifthly, never store tools or other objects inside the panel. This can create a safety hazard and damage the equipment. Electrical systems are complex and require careful attention to detail. By following these guidelines, you can help ensure the safety and reliability of your electrical installations.